SR-IOV Demo. Here is the SR-IOV environment. It's an OpenShift cluster deployed on a CentOS physical host with SR-IOV NIC plugged in. I will introduce a little more about the environment since it's a little different from the common KubeVirt environment. First, before deploying the environment, please make sure hardware virtualization, Intel VT, and IMO are enabled in your BIOS and kernel. We can check that by the message. Here are the parameters we added in kernel. And we also need to load VFIO PCI kernel module since KubeVirt uses VFIO to pass SR-IOV VFs through into the VMs. After that, you need to reboot your machine and then enable the VFs. Let's check the VFs. You can list your VF by LSPCI or IP link. Here are the VFs. And now you need to prepare a Kubernetes or OpenShift cluster. Here is my OpenShift cluster. Then deploy KubeVirt and SR-IOV components. Now we can deploy the SR-IOV components by KubeVirt Ansible. In order to save time, I already deployed them in my cluster. Let's check them. We can see both the SR-IOV CNI and the device plugin port are running, and a network attachment definition is created. Let's check it. We define a resource name annotation here. We use this annotation to decide which device to allocate for the network. This mechanism can be used to add CNIs like OVS CNI or Bridge CNI. One more thing we need to pay attention is a config file on the etc PCI-DP. Let's check the config.json file. SR-IOV DP uses this config.json to determine which PFs should be used to allocate VFs from. This config.json file is created on array node during deploying the SR-IOV components. But by default, KubeVirt Ansible doesn't config any PFs, so you need to add the PF PCI IDs to the config.json manually. We can see the IDs in LSPCI is same as the config.json. In the future, we will make the device plugin to automatically discover all the available VFs. Now, let's see how SR-IOV device plugin detect the VFs. I would like to show you the log inside the SR-IOV device plugin port. SR-IOV DP is for VF device discovering, device state report, annotation, and health checking. Here are the VFs detected by SR-IOV DP port. Kubelet also updates the checkpoint file with port to VFID mapping. Let's check the Kubelet checkpoint file. And Mountain CNI retrieves VFIDs from this checkpoint file and pass it along with CNI configuration to SR-IOV CNI. Okay, let's create a SR-IOV VM to see what will happen. Here is the VM spec. Create the VM. Then connect the VMI console by virtctl. Please wait a few seconds till the VMI starts. We use Fedora image here since it has kernel driver for Intel NICs. The VMI is starting. Log in with Fedora. Let's check the interface. We can see the ETH1 interface here. The interface gets an IP address since the physical network has a DHCP server set up. Let's try to ping a public DNS address. It's available. Let's install PCI utilities. Please wait a few seconds here. Okay, the installation is done. Now we can see the Intel device inside the VM. Let's get out the VM and check the SR-IOV device plugin port again. We can see some information about the VF is consumed by the SR-IOV VM. Okay, thank you.